Alright guys, this is our walkthrough video for Algebra 2's Chapter 1 practice test. So I'm going to kind of go through all of the problems here. If you're only having problems on certain ones, feel free to kind of skip a around and find the problems that are going to be most beneficial for you. So these first few, we're just going to be trying to plug in values of x. So if I want to plug 3 into f here, I'm just going to have 3 to the second power minus 1, or whatever we want to be substituting in. It's a good habit to always put it in parentheses. So I get 3 to the second power, that's going to be 9. 9 minus 1 is going to give me 8 for my solution there. It's not too bad there. If I go over to g, I'm trying to find the g of 23, so I'm going to plug in 23 into my g function. So that'll be the square root of 23 plus 2. Again, here the parentheses don't really help or like hurt, but again, just a good habit to be in. So 23 plus 2 is going to be 25. Square root of 25 is going to give me just a regular old 5. All right, so then down here on 3, we're trying to say, hey, let's find the value of x when f of x is equal to 15. So this is basically saying, hey, my y, or this side of my equation, is going to be my 15. So I have 15 is equal to x squared minus 1. So now it's just a fairly simple algebra problem. So I can add a 1 on both sides. I know I don't have to worry about trying to factor this because there's no x to the first power term, just an x to the second power. So add over the 1 and I get 16 equals x squared. And then to get rid of that square, I need a square root both sides. So take a radical of both sides. And then I'm going to get x is equal to plus or minus 4. Now the plus or minus is important. You need that, or you only have half of these solutions. Because whenever you are the one who is putting the square root there, you need that plus or minus. On a problem like 2, when the square root is already given to you and it's just positive, that's when you don't need to worry about the plus or minus options on it. Number 4, trying to find the g of x when, find x when g of x is 6. So that would be 6 is equal to square root of x plus 2. So then here, I want to square both sides to get rid of this radical. If I square both sides, I get 36 equals x plus 2, because the square root is going to go away. And then I have to get rid of that 2, so I'm going to subtract 2 from both sides, and I get that x is equal to 34 in this case. So hopefully not too bad. That's mostly review stuff of Algebra 1 level stuff, so it shouldn't be all that bad for us. Let's hop down to problem 5. So we're trying to state the domain and the range of this particular function. So I see I have a parabola shape, so it's going to go left forever, it's going to go right forever. So my domain is going to be all real numbers. So I can write that with my all real number symbol. I can say, hey, my x values are greater than negative infinity, but less than or equal to positive infinity. Sorry, you actually don't need the or equal to's on there because it's infinities. Or I could also say in interval notation, it's between negative infinity and positive infinity. Okay. Any of those formats is fine. Again, at this level for domain and range, all I care about is that you can convey to me what it is. I'm not going to be really picky about the format. Later on in the year, I'll try and get you more and more used to this format here, though. Then range. Looking at this range, the lowest point that this graph ever gets to is right here. And that has a y value of negative 2. So this is negative 2 and larger is my range. So that would be any y values that are greater than or equal to a negative 2. So that's one way of writing it. If I wanted to do that in interval notation here, I would say, well, it could be negative 2 up to positive infinity. Okay, so again, whatever format you're more comfortable putting that in, that's fine. Do not feel like you have to put it in both forms by any means here. 6 and 7. So on problem 6, so I'm saying, well, I have fractions that are being added. So I could try and get common denominators here, and that is one way to do it. We can kind of shortcut it though. So what I can do is say, well, the common denominator of 4 and 3 would be 12. So I would need to get a common denominator of 12, and then I could add them, and then I could have just one fraction there that I could work with. But if I know it's going to be 12 and it's going to be on the bottom of a fraction, I can do a little bit of a shortcut, and I can multiply the entire problem, left and right sides, by 12, by that common denominator. Now what that's going to do is get rid of all of my fractions right off the bat, which is typically the part of the problem which people hate the most. So if we do that, 12 times x over 4, well, I can reduce 12 over 4 down to just 3, so that's going to be 3x. 12 times x over 3, well, I can reduce 12 over 3 to just down to 4, so that's going to be plus 4x. And that is equal to 2 times 12 is 24. Well, then I can add these. 3x plus 4x is just going to be 7x's equals 24. And then very simple, to get the x by itself, I want to divide by that 7. So divide by 7s. And I get x is equal to 24 sevenths. So again, leave those as fractions. Don't give me decimal a approximations when there's not a need for it. All right, over here to number 7. So here I have an x to the second, and then I have an x to the first power here. So whenever I see that versus here, where I didn't have that x to the first power term, I definitely need to try and solve this by factoring or the quadratic formula. Since there's not a number in front, factoring is going to be pretty easy for me to try and check. So I'm going to be looking for, is there some value, it's going to be x here and x here, some value that can multiply to be negative 27 and add to be a positive 6. So that's going to be 9 and negative 3. So if I do 9 and negative 3, these multiply to be that negative 27, and 9 plus negative 3 is going to add to be that positive 6. So there it is factored. Again, if you've learned other methods of like factoring which you're more comfortable with, by all means do them. I'm never going to try and force the way that you're going to see me on you guys trying to factor. So whatever you're more comfortable doing. But now that it's factored, we're equal to 0, so we can do that zero product property on it. So I can say, hey, when is this 0? When is this 0? So you can probably shortcut it, but I always try and show the full version just so that you understand exactly what's going on if you're a little bit confused. So I set both of these equal to 0, and now I can solve these for my two x's. Subtract 9, I get x equals a negative 9. Over here I add 3, x equals a positive 3. So those are my two solutions for x. All right, let's head over to the back page. So here on problem 8, we're trying to get a sketch of this particular graph. So let's talk about what we know as far as nice, pretty whole numbers here. So this is going to be the base graph. I'll kind of sketch it in here. It looks kind of like that, right? Kind of follows that general shape. Now that's not going to be our actual graph, but it's all centered around our vertex here at 0, 0. Now this graph is going to do a few things to it, right? This minus 2 is going to actually move my graph to the right 2. So now I'm over here. But then the minus 1 will actually move it down 1. So here is where my vertex actually ends up being, right? And then it's going to follow the general shape of a parabola. So it goes up 1 over 1, and then it goes over 2 up 4. And you can kind of sketch in that general shape there. If you're having trouble with those rules for the shifts, that's totally fine. What you can do is make a table, like make an XY chart, and then plug in points, and you should be able to see the graph. I guarantee that they're all going to be nice, pretty whole numbers. So feel free to do that if that makes you a little bit more comfortable. All right. Now, 9, 10, 11, and 12 are all going to be talking about parts of this actual graph here. So to get my x-intercepts, well, if I made a table, I could find these, but I also know that from here, this is going to be at 1, 1, 2, 3, and 1. My x-intercepts are going to be 1 and 3. My y-intercepts are going to be up here at 1, 2, 3. So y-intercept of 3. And then my domain, again, this is a parabola, so it's going to go left and right forever. So my domain is going to be all real numbers. Or I could say from negative infinity to positive infinity. Or I could use the notation negative infinity, comma, positive infinity. Again, any one of those, whatever you're more comfortable with. And then the range, my lowest point here is at -1. So my range is going to be any y value that is greater than or equal to -1. Or I could say in interval notation from -1 up to a positive infinity. Oops, sorry, you couldn't see that. So again, formatting, don't worry about the format. Just give me whatever you find most easy a way to describe what the domain actually is, or the range. Even if it just comes down to you are writing out a small sentence about, hey, here's what the domain and the range is. At this level, right now, that's all I really care about. Eventually, I want you to get more comfortable with the interval notation, but for right now, just tell me you know what it means, or what it is. Okay, so you look at 13. So 13, we have a little bit of a situation here. We're going to start off with $50 a month, and every day we spend $6. How long is your money going to last? Right. So to start off, we're going to write an equation that represents the amount of money we have each day of the month. So our rate of change here is we're losing $6 every day, and our initial or our starting point is $50. So whenever I see my kind of rate, that's my slope equation-wise, right? All slope is a rate of change. Slope's more of a graphical term, whereas rate of change is more of a kind of real-world situation type term. So I'm losing $6 per day. That's my rate of change. And I'm starting at 50, so that's going to be where my initial point, or when my x value is 0, that's my y-intercept. So that I can go straight to my linear model here and say, well, this would be y is equal to -6x, because I'm losing $6, so I need to have it be negative, where x is my number of days, plus $50 is where I'm going to start. Okay. So now let's create a graphical representation of that. Fancy way of saying, hey, let's graph this so that I can see a graph of how this is going to look. So if I do this, let's get an x and a y axis. I only really need the first quadrant because I'm only going to be dealing with positive values here. If I do 10, 20, 30, 40, 50, 60, make sure we label things so that we know what units we are in. And this is dollars. And then here's going to be my days. 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay, so labeling those out. Here's my days. So I know I'm going to have one point here at 50. And then if I can find a second point, it's going to be a lot easier for me. So I could do at day 1 is going to be $44. But looking at my units, I could do that, but just how my graph is actually scaled, I'm going to go to the next kind of nearest $10 a amount here. So if I go losing $60, in 5 days, I'm going to be losing $30. So after 5 days, I would be at $20. So I'm going to put my second point there. Again, you can find your second point anywhere. I'm just picking one that's going to be a nice whole values based off of how I made my x and my y axes. So then I can grab my ruler and I can draw my little graph going through those like so. Okay. So then question 15 is how many days will it take for your money to run out? So I could look at my graph. Now my graph is not going to be perfect by any means here. So I'm going to try and use an actual E equation here to use the E equation to solve it out. So I can say, hey, when is my value going to be 0? So 0 is equal to negative 6x plus 50. Right? So then I'm going to subtract the 50. And then I need to divide by negative 6. So I'm going to get x is equal to negative 50 over negative 6. And that's not really a fraction that we kind of want to leave things in. We probably don't want our answer as a fraction at all. So if I grab my calculator and just do 50 divided by 6, I get 8.333 days. Right? So that is going to be when I run out of money. Now, my graph, again, my graphs are not perfect at all, which any kind of hand-done graph isn't going to be. So it's like mine showing, hey, I'm going to run out at like a little after day 10, where it should be kind of crossing here. But again, if your scales aren't perfect, it's never going to be a perfect graph. So don't worry about that. That's why you kind of want to do this algebraically, unless you have a graphing utility for doing that. So that is it for the Chapter 1 test. If you have any questions, please be sure to ask me as soon as possible, and good luck.